Welcome everybody. This is a lovely question, and please be reminded that geometry is not only necessary for your high school exams and as well as middle school exams, but it improves your ability to think, specifically in this day and age where gaming and gaming technologies are on the roost. So if you are very good in geometry, then you have a lot of opportunities. So having mentioned that, what is my objective now is to improve your geometry skills. And having mentioned that, I would like to request you all to like, subscribe and share this video. So my device has helped me to get a good circle. I'm thankful to the device. So foremost, what I wish to do is I need to draw two isosceles triangles. So this is a center. Actually, foremost we should have drawn the triangles, but drawing the triangle and drawing the tangent, or I should say drawing the circle in such a way that it is acting as a tangent, it's a complicated affair. So I want to go in this fashion. So what we need to do is we need to draw the tangent. So I will draw the tangent first. So this is a tangent. Now this is actually the base of a triangle. Now, having given that, what I have to do is I need to now let me extend this a little bit more, because on this end I have made that extension. So I will also have to extend this. Okay. So having extended it, this has to hit the triangle at this particular point. So let me have this hit, and then I need to extend this little bit, and then there is a hit here. So I need to make sure that they are hitting it, or I should say the lines are able to hit the center. That is the ultimate objective. Okay, so let me try. Okay, I'm trying to do some justice to the image. So okay, so that is how the triangles are situated, and it's an isosceles triangle. That means this side is same as this side, and this side is same as this side. So you got two isosceles triangles. So we can very well name them as A, B, C, D, or whatever you want. So let me name them as A, B, C, D, E. So two isosceles triangles, and not only that, they are actually having an angle of 30 degrees. So since it's isosceles triangle, this would be 30, this would be 30, this is also 30, and this is also 30. These are the information given, right? And I'm just feeding that information here. So having given you this information, now what is the requirement? The requirement is we are expected to find the area of this part, the blue dots. You follow me? See the beauty of this question. They are asking us to find the area of the region that is dotted with blue color. So this is exactly what we need to do. Now the question is, how are we going to do that? Okay, so foremost, this is the picture given. So let me probably give the center name as say C, right? Now foremost, what I wish to do is I would have to drop a perpendicular from the center to the tangent. Okay, now if you remember, I said this is isosceles triangle. Triangle ABC, and let me write that down. Triangle CDE are isosceles triangles such that AB is equal to BC is equal to CD is equal to DE is equal to 1 meter, right? That information is also given. So having given these information, what I wish to do is I would like to drop a perpendicular from the center to the tangent. Also AE is a tangent. AE is a tangent to the circle. So if I were to drop a perpendicular, it would look something like this. From here you drop a perpendicular to the center, right? Now by tangent theorem, there is a theorem called tangent theorem. By tangent theorem, what do we know? The angle between, I have to change this because there is two C's. Apparently I placed a C here and I also placed C here. I changed it to O. Okay, that would be much better. Now by tangent theorem, the angle made between OC and CE will be 90 degrees. So let me write that down. By tangent theorem, the angle made by the line, it can be any line, a line drawn from the center O of the circle to the tangent will always be 90 degrees. So this is a theorem, tangent theorem. It will always be 90 degrees. So having got that, probably I will write that down. So I can use a different color. So this entire thing is going to be 90 degrees. This is 90. Now this is 30. I already mentioned to you, we are dealing with an isosceles. This is 30. So this angle is going to be 30. Right? This angle is going to be 30. But this is 90. So what would this angle be? This angle is going to be 60. And similarly, there is a perpendicular on this side. This is going to be 90. This is going to be 30. And this angle is also going to be 60. This angle is going to be 60. Right? So that is one inference that we need to take into account. Now what I wish to do is I would like to connect B with O. I know this is a little bit tricky. We need to make the connection. It has to be it has to be a straight line, but apparently we are not getting apparently because of the figure there isn't a straight line. I actually wanted it to be a straight line, but apparently the line seems to be different, but it's still okay. We are not getting a straight line, it's still okay, but the concept is not going to be changing, right? So let me connect this. So you got a triangle like that over here. Let me connect these two figures. I should say these 2 points. So you got it something like this. Now this is 60. Right now this is the radius. And I already mentioned to you this is the radius. Right? And we are dealing with an isosceles triangle. So let us, or I should say we are dealing with equilateral triangle in this case. Now we can clearly see that this is the radius. This is going to be 1 unit. This is also a radius. This is also going to be 1 unit. And this BC is also 1 unit. So all three sides are equal, right? So all three sides are equal means we are dealing with the equilateral triangle. So this is going to be 60 degrees. Now this is 60, this is 60. What would this be? This is also going to be 60, right? Because it's an equilateral triangle. So this is going to be 60. So that is an important inference I would like to draw your attention to. So let me reiterate. Now this is 1 unit, we know. This is also a radius. From the center I am drawing it to the end of the circle, right? Of course it would have been much better, it would have been a straight line, but apparently since the figure, you know, there is an element of human error, and it doesn't matter because the concept is critical. So this is going to be 1 unit. Now this is 1 unit, this is 1 unit. Already we know BC is 1 unit. See, BC is 1 unit. So all these three sides are equal. Because all these three sides are equal, we are dealing with the equilateral triangle, and the angle of an equilateral triangle is 60 degrees. So this is 60, this is 60, and you got this 60. Now what I'm going to do is I'm going to calculate the area of the sector, area of the sector OBC. Now the sector formula, right, is theta over 360 multiplied with pi r squared. This is the sector formula. Now what is theta here? Theta is going to be 60 divided by 360 pi. My r is going to be 1. Radius is 1 unit. So you square it. Now 0, 0 gets cancelled. 6 divides here 6 times. So this is going to be pi over 6. So this is one region, right? This is one region. This is one. This is also a sector. OCD is also a sector, and clearly this is 60, and this will also be 60, right? So we can also calculate, but I don't want to calculate that. It is sufficient that I calculate this and then extend it. Now, after finding the area of this sector, what I wish to do is the next thing is I need to find the area of the triangle, right? Area of the triangle OBC. That's an equilateral triangle. So what is the area of the equilateral triangle? Half into the sides A into B into sine. The angle is 60. So this is going to be half into A is 1, B is 1. Sine 60 is root 3 over 2. So this is going to be root 3 divided by 4. This is the area of the equilateral triangle. Now the area of the shaded part, right? Therefore the area of the shaded, right, or the blue region, right? So let me write that blue part or blue shaded. You can put whatever representation you want. So I just want to write it as blue shaded part. Now that is going to be equal to area of the sector. So area of sector, what is that? OBC minus area of the equilateral triangle. That's going to be OBC, right? So that is going to give me this blue region. So that is going to be equal to area of the sector. What is the area of the sector? Pi over 6 minus, this is going to be root 3 over 4, right? So if we were to take the LCM as 424, this is going to be 4 pi negative 6 times root 3. So this is what I've got, right? So this is for one region. So we need for two regions, right? We need for two regions. So if we were to take 2 out, and this is going to be 2 pi negative 3 times root 3 divided by 24, which is nothing but 2 pi negative 3 times root 3 divided by 12. So this is for one part. So therefore for two parts, therefore total area of the blue region, blue shades, right? Blue shade region or blue shaded region, that is going to be 2 multiplied with, there are two parts here. I have just calculated this part, so you need to multiply by 2. So 2 times of 2 pi negative 3 times root 3 divided by 12, which would give me 2 divides here 6 times 2 pi negative 3 times root 3 divided by 6 square units. So this is the final answer. I hope you enjoyed this question. Thank you.